All right, starting off with a quick 6.4 review here to catch you up after a fall break. Hope you had a good one. Let's get to it. This is just review what we did right before we left. We were in radians right before we left, believe it or not. And the first thing we're going to talk about is what quadrant certain angles are in. So the first one right here says 3 pi over 4. I've drawn already on here a picture of what our unit circle looks like or our quadrants look like with the pi over 2 at the top, the 1 pi over here, which is really 180 in degrees, 3 pi over 2, 1.5 pi there, 2 pi there. So every 90 degrees is like pi over 2 or half pi. So the first one, part A, says 3 pi over 4, which means you're going to go 3/4 of the way to pi, which is going to put you about, if you start here, it's going to go about to right there, 3/4 of the way. That's quadrant 2, so we're going to say that's quadrant 2. The second one, 7 pi over 6, that's really 1 1/6 pi. If I change it to, mixed numbers, I'm going to go to 1 pi, 1/6 of another one, about right there. That's quadrant 3. So I'm saying quadrant 3. The next one says negative pi over 3, so I'm going to go the other direction. And also, this is just negative 1/3 of the way to pi, so I'm going here about 1/3 of the way. This is halfway, so I'm not going quite that far. That's quadrant 4. One more says 5 pi over 3. 5 pi is really 1 2/3 pi. So I'm going to go start at the beginning, go 1 pi, 2/3 of another, taking about, right there, a little bit past the halfway down there. So that also puts me in quadrant 4. Hopefully that's coming back to you a little bit. Best thing to do is base everything on pi, where pi is, how does your angle relate to where pi is on your circle to get your quadrant. And that's going to be very important. Coterminal. Coterminal means the terminal side ends up at the same place, which means when we did degrees, we added 360, subtracted 360. So the radians, 360 is really 2 pi. So I'm going to take 5 pi over 3 and add 2 pi to it. Also going to take 5 pi over 3 and subtract 2 pi. Now, 2 pi is really 6 pi over 3. Really, all I'm going to do when I do this is I'm going to double the denominator right there. And 5 plus 6 is 11, so it's 11 pi over 3. That's a positive one, it's coterminal. If you subtract 2 pi, do the same thing. Again, this is really 6 pi over 3. So if I do 5 minus 6, that's negative 1 pi over 3. And those are both coterminal, or would look exactly the same as the 5 pi over 3. The terminal side would be the same place, but they do have a different measure. So coterminal, add 2 pi, subtract 2 pi. Okay, convert to radians. What we do when we did this the other day is the degrees must cancel. I don't know why I just put equals right there. So keep going back. There we go, times. So I'm going to multiply times pi over 180 degrees. And the reason that you do that is because you need your degrees to cancel, which they do here. So I'm just going to punch in 135 over 180 in my calculator and let it reduce the fraction for me by hitting math frac. And it tells me 3/4, so it'd be 3 pi over 4 radians. That should have been pi radians right there. So that's 3 pi over 4 radians. The quick way we talked about in class the other day was just doing this. Remember, it should be negative also, sorry. Is just do this. If it's in degrees, you can just do this over 180, reduce it, and just put a pi with your answer, and that will always be the same thing. I didn't tell you that though. Okay, convert this one to degrees. I'm going to show you 2 ways real quick. One way is, remember, pi is really 180 degrees. So one thing you could do is you could just substitute 180 where the pi is and just punch that in, and you would get 210 degrees. That's one way. The official way is you need the radians to cancel, so that's 7 pi radians over 6. You want to change it to degrees, so you're going to say 180 degrees over pi. And the last slide we did pi over 180. This is 180 over pi. And what happens is your pi's cancel, which makes you end up the same thing as we had up here, which is going to be 210 degrees. So either way, it's fine. A couple more things here. Huge. This is so important. This is what a radian is. 1 radian, 1 theta is S over R, where S is your arc length, R is a radius. And there was a video before this one that explained that like crazy, went over and over and over it. I guess I could do one little picture here, but like if I have that circle and the radius is right there, that's a radius. Let's say that radius right now is the same length as that arc right there. If you stretch out that arc and it's the exact same length as that radius. That angle that it makes right there is 1 radian. That's what 1 radian is, which means 2 radians would be if I went an arc about that big right there, and it's twice as big as that radius. If it's twice as big as that radius, it would be 2 radians. That's why the whole circle is 2 pi, half the circle is 1 pi, because circumference is 2 pi r. That's all on the last video. Please go back and watch it if you need to. Still there. They never go away. You can watch them as much as you like. So this one, it says, in a circle with radius 10 inches, an arc 20 inches long subtends an angle of how many radians? So what is the angle that makes an arc 20 inches long in a circle that the radius is 10? Well, very simple. The angle is the arc length, which is 20 inches, over the radius, which is 10 inches. So it is 2 radians. That's all you have to do. Radians is the arc length over the radius. The arc length over radius. And believe it or not, that was a lesson right before we left. Pretty much that's all there was to it. We'll probably do some problems like that tomorrow, maybe add one little thing to it and kind of get back in the groove a little bit. So I hope you had a great break. Look forward to seeing you again. See you tomorrow.